Okay, so here are the take-home parts that you guys are supposed to do. This will be a great review in terms of how to, implicit differentiate and lines, tangent to curves, and everything else. So, question number one, wanted you to find dy dx. This is implicit differentiation. So when I take the derivative of this, here it's just normal. Here it's a product rule, and we're going to take the derivative of y with respect to x. And here we have to take the derivative of y with respect to x using the power rule. So we're trying to find dy dx, so we want to isolate it. So here we go. We're going to start with the derivative. We'll start with, and I'm going to bring this over here because I'm probably going to need a lot of this space. So derivative of x squared is 2x, and then minus. Now this is what's important. The product rule follows the minus sign, so we're going to open up a set of parentheses because I'm going to have to distribute that minus sign through. Here's my first. Derivative of the first is 2 times my second, y squared, plus the first, 2x, times the derivative of the second. That's going to be 2y, and then dy dx. We're done with the product rule. Close the parentheses. Equals the derivative of y to the fourth is 4y cubed, and then dy dx. Next thing I'm going to do is I'm going to distribute that minus sign through to make sure everything inside parentheses changes sign. Simplifying this, 4xy, and then dy dx equals 4y cubed dy dx. Now remember, what we want to try to do is we want to try to get the dy dx's on the same side and leave everything else on the other side, because we want to get a dy dx by itself. If we put them all on the same side, we're going to be able to factor that out. So I'm going to add 4xy dy dx to both sides. All right, and that's going to give us 2x minus 2y squared. These will cancel, equals 4y cubed dy dx plus 4xy dy dx. I'm going to bring this up here. My left-hand side is going to stay the same, so 2x minus 2y squared. My right-hand side, the reason why we did this now is because I'm going to be able to factor out that dy dx. That's going to multiply then what's left, 4y cubed plus 4xy. Okay, I want to get dy dx by itself, so I'm going to divide both sides by this 4y cubed plus 4xy. And now that will leave me with dy dx is going to equal the 2x minus 2y squared, and then all of that's going to be over 4x cubed plus 4xy. And the only other thing we can do is, and I'll do it because I'm running out of room, is we can pull a 2 out of the top, and I can pull a 4 out of the bottom, but I can only really reduce it by 2. So I'm going to pull a 2 out of the top, leaving me with x minus y squared. I'm going to pull a 2 out of the bottom because that's what's going to be able to cancel, leaving me with 2x cubed plus 2xy. And then what happens is these two go away, so I'm going to get a final answer of x minus y squared, that's this, divided by, even though I can still take a 2 out of here, I don't want to do that because it won't cancel with anything. And then that turns out to be, my final answer. Okay? So there's dy dx. All right, question number 2, and that will end this video. On question number 2, same type of question, except this time what we're going for is we're going for the equation of a line tangent to the curve. So if we're going for the equation of a line tangent to the curve and you know the point, guys, always start off with, because this is where I'm going to finish the problem up here, y minus the y coordinate, which is 2, equals m times the x coordinate, x minus the x coordinate. So get that going. The only thing I need to find out is what m is, and what m is going to be what dy dx is going to be. All right? So we know that m is going to equal dy dx. Okay, so I need to find dy dx. Here's my equation. I need to take its derivative. Starting here, I have 2y and then dy dx. I have a product, so it's minus everything I'm about to do. Derivative of the first is 3 times the second, which is y, plus the first, which is 3x, times the derivative of the second, dy dx, plus the derivative of 2x squared, that's 4x, equals the derivative of 4, 0. So 2y dy dx minus 3y minus 3x dy dx plus 4x has to equal 0. Okay? So what we can do here, is we could simplify, or we can realize I'm looking for dy dx, and it might be easier to find dy dx by taking what we know about x and what we know about y and plugging them in. So that's what I'm going to do. So this is 2 times y, which is 2, dy dx, minus 3 times y, which is 2, minus 3 times x, which is 3, dy dx, plus 4 times x, which is 3, all that has to equal 0. Okay, so another step, 2 times 2 is 4, so we have 4 dy dx's, minus 6, minus 9 dy dx's, plus 4 times 3 is 12, equals 0. So I'm going to combine my dy dx's. I have 4 of them, and I have negative 9 of them. That's negative 5 dy dx, equals, I'm going to save a step. I'm going to add these two together, and that's a positive 6. And I'm going to bring it to the other side. That's going to make it a negative 6. So then I'm going to divide both sides by negative 5. So I have dy dx is going to equal that negative 6 divided by negative 5, and that's 6/5. That is what I put in for m. So here we go. We're not done yet. Y minus 2 is equal to 6/5 x minus 3. Y minus 2 is equal to 6/5 x, and then 6/5 times a negative 3 is minus 18/5. I have to add 2 to both sides, so when I add 2 over here, it looks like that. But when I add 2 over here, it's going to be in terms of fifths. So here's 2. Here's 2 in terms of fifths. Final answer, y is equal to 6/5 x, negative 18/5 plus 10/5 minus 8/5. There's the equation of a line tangent to the curve. Okay, so that ends this video. Those are the first 2 great part 2 questions. So you probably should be very knowledgeable about how to do these 2 for the midterm.